Look up at the winter sky and easily spot the 3 stars of Orion's belt. If you look into the hunter's sword, that middle star is actually a massive glowing cloud of gas and dust. This is the Orion Nebula, located 1,344 light-years away from Earth. Early astronomers struggled to explain the intense colors radiating from this cloud. The bright green hues found in its outer edges didn't match any known substance, leading scientists to hypothesize a completely new fictional chemical element called nebulum to explain the glow. Modern analysis reveals a more violent truth. The light comes from extremely rarefied, highly ionized oxygen, a state requiring an immense energy source to exist. The Orion Nebula is a volatile stellar nursery, currently ripping itself apart as its own newborn stars dismantle the clouds that birthed them. Deep inside the cloud, the source of this energy is found in a tight grouping of extremely hot young stars, known as the trapezium cluster. This chart compares our own sun to the heavyweight champion of this group, Theta 1 Orionis C. It has 40 times the mass of our sun, burns at a blistering 45,000 Kelvin, and radiates 250,000 times more light. A star of this scale emits powerful stellar winds, high-energy radiation acting like a cosmic leaf blower, clearing out all raw interstellar gas in its vicinity. These massive stars act as localized radiation bombs, blasting away the raw materials needed for anything else to grow, and making the environment hostile to the rest of the cloud. Curious. Switching to infrared allows us to see activity hidden from visible light, peering through dark clouds of dust the heavyweights haven't blown away. Deep in these shadows, telescopes have discovered over 700 protostars and roughly 180 proplights, or protoplanetary disks. These proplights are dense, spinning whirlpools of matter, reeling in gas and dust to build entirely new planets. These smaller systems are in a race against time, desperately trying to construct their planets before the neighboring heavyweight stars blow their building materials into deep space. Beyond the radiation winds, the newly born stars also engage in kinetic warfare. Ionized particles accelerate through the magnetic fields of these young stars, shooting massive jets of material out from their poles. Known as Herbig-Haro objects, these jets travel at hundreds of kilometers per second. When these ultra-fast streams slam into the surrounding gas, they trigger immense swirling vortices and chaotic shockwaves that ripple through the region. Young stars also fire off a swarm of bullets, massive projectiles tipped with glowing iron atoms that hurtle through the dark. These bullets are hundreds of astronomical units wide and easily punch through the thinner hydrogen clouds, sending out secondary shockwaves across the nebula. The interior of the nebula is a chaotic crossfire, dismantled from the inside out by intense radiation and high-speed kinetic impacts. Pulling back reveals the full scale of the wreckage. The Orion Nebula belongs to the Orion Cloud, a massive structure stretching across hundreds of light-years. The massive red curve of Barnard's Loop marks the site of ancient supernovae from 3 million years ago, proving this entire sector operates on a cycle of explosive violence. The internal warfare has taken a staggering toll. Through constant stellar winds and kinetic impacts, the nebula has lost 60% of its original mass. In roughly 100,000 years, a brief cosmic moment, the remaining gas will be stripped away, and the nebula will completely vanish. Once the glowing dust clears, a naked, open star cluster will be left behind. These young stars will drift together for a time before wandering off to find their own paths through the galaxy. These glowing clouds are fleeting, violently chaotic moments of self-destruction, captured by our telescopes just before they vanish into the dark expanse of space.